As you have seen, many of my colleagues, they have taught about Colab, means they have given an actual visualization what the things are happening in Colab. Okay, my screen is visible. Okay. So I'm having one very interesting site, cs.stanford, and this is regarding Cypher dataset. Okay, so they are taking Cypher dataset, they are training it, and they are trying to predict the output. They are trying to predict the classification. So as you can see in this, there are some statics given over here. So why we have actually tried to visualize this website to you, because you will get a more insight what exactly is happening after particular layer. So after explaining this particular website, I guess all of the doubts which you might be having will get clear. So see here, forward time, backward time is after doing forward propagation, we are doing backward propagation in order to reduce whatever the loss function we have. So that backward time, forward time, everything like statistics and all are given over here. Means every time here it is getting updated. Means forward time is getting updated in milliseconds itself. So what it happens for every input, it is taking an input image now. It is and it is calculating the forward time for that particular image, and along with that it calculates backward time for that image as well. Then it calculates the classification loss. Since right now you won't be able to see the right prediction, because this model is undergoing training right now. So we can see the classification loss as very high because it is still in the training phase, since it is a live demo. So you can see the training accuracy is very less, but it is still going to train. It is still seeing the examples. As you can see, the examples over here are increasing continuously. So they will be increasing again. So we have defined the learning rate. Here you can play with the learning rate. You can play with this hyper parameters. Like you can change the batch size. You can change the weight decay. You can change the learning rate. With these all are nothing but the hyper parameters. So you can change this and you can see what outputs you are getting. How the outputs are differing when you are changing this all parameters. This is why that is why we have decided to show this website to you. You will be getting the link of it as well at till tonight. So these are nothing but the layers that we have seen so far, like convolution layer, pooling layer, again convolution layer, pooling layer. Okay, so what happens in convolution layer? We are extracting features. What happens in the pooling layer? There is dimension reduction, isn't it? After dimension reduction, what we are doing in pooling layer, there is not only dimension reduction, but we are extracting the most prominent features of that particular region in pooling layer. So these are nothing but convolution pooling layers. And even in this, they have defined filters that we need to apply. Okay, so here filters are 16 filters they have applied. Here they have applied 20 filters. And stride, they have also applied stride of 1. Stride is nothing but the number of pixels you are going to move ahead. The filter number of pixels by which filter is going to move ahead. They have given padding of 2, and activation function. You can play with the activation function as well. You can change the activation function and see how the output changes. So the main part is in this, how the visualization is there. In model, we can't see the exact visualization. This is nothing but an input image. It is a 32 by 32 image, and 3 represents nothing but a channel, number of channels. So this is an image, and we are applying convolution operation in this first. So in the convolution operation, you can see that these all are, what are this? These are nothing but the feature maps. We have applied 16 features, isn't it? As we have defined over here, 16 filters are applied. And what is the output after applying those 16 filters is displayed over here. So every time as image changes, suppose a filter is trying to detect a horizontal line, a filter might be trying to detect a vertical line, or a curve detecting filter might have been applied. So all the output after applying the filters are displayed over here. And this is nothing but activation, and these are the activation gradients. So what exactly is activation gradients? As you can see, there are some small patches. So this is nothing but the focused area where it has seen some gradation. These are nothing but areas where it has seen some gradation. It means what if there is a color gradation or a feature they have tried to extract, this is nothing but the activation gradients that they have, this filters have understood. And you know the concepts of weights and weight gradients as well, means what are weights and weights gradients, like neural network. Here weights are nothing but the filters that we are going to apply in order to extract the features from them. After performing convolution operation, we have the ReLU function, ReLU layer. Okay. As you can see, the dimension remains the same, that is 32 by 32 into 16. 16 denotes number of filters that we are applying. Same here, after applying 16 filters, we are getting 16 different outputs. These are nothing but the output that we get after applying the filters. We called it as a feature map. Again, in the ReLU layer, we have feature map, and the same activation gradients are displayed. You can see that they are changing always, because as the input image will change, of course, the feature map will change, and of course, activation gradients are likely to get changed. Now in this pooling layer, what happens in the pooling layer means we have taught that in pooling layer there is dimensionality reduction. That is, we are reducing the dimensions. So as you can see, in till ReLU layer, there was 32 by 32 dimension. Now it has become half. So that is what the function of pooling layer is, to extract the most prominent feature from that feature map. Okay, so these are again the pooling layer outputs, and the activation gradients are nothing but where our model is able to, the filter is able to see the prominent gradation in that particular image. So it is nothing but activation gradient. Again, they have applied convolution layer. Since this is a convolution layer, so dimension will not get reduced, it will remain the same. Okay, and also we have applied padding of 2. So dimension reduction will not happen, will not take place. And then the ReLU layer again. Here also dimension reduction will not take place. And again, the same thing is being followed. Like we are applying filters. Filters are nothing but weights. And after applying filters, we are getting a feature map. So all these are nothing but feature maps, and these are the activation gradients. Again, the pooling layer. Since this is a pooling layer, the dimensionality reduction will take place, and we have 8 by 8 into 20. Now in this layers we have applied 20 filters, so hence into 20 is there. 20 different filters are applied. So these filters might be anything, like as I told, detecting of a vertical line or a circle or a edge, like curve, anything. And here we have also mentioned that stride of 2. Here stride until last layer, stride of 1 was applied, but in this stride was 2, because this is a pooling layer. In pooling layer, most probably we are taking the stride of 2. Again, the convolution layer is applied. Since convolution, so no reduction in the dimensionality takes place. So again, these are activations. Activations are feature maps, and these are the weights that they are applying. And weight gradients, what are weight gradients? That is the gradation in the color in the weights that they have observed. It is nothing but weight gradients. So again, ReLU, and then pooling layer would be there. And last is nothing but for fully connected layer. We call it as a dense layer as well. So in this fully connected layer, all the features that has been extracted by convolution layers are aggregated, and all together after fully connected layer, we are applying softmax function in order to give the probability value. So what is the probability that this is the feature? It belongs to this particular class. So since this model is training, it is undergoing training. So you may see that some of them might have not been detected right. But after completion of training, surely the model is going to detect the classify right image with the right class. So here the training is going on, and they have seen that this is a horse. So they have given the probability of horse is much more than the dog and then the deer. So like that, the model is trying to classify a image based on the features that it has extracted. So you will get the link of this particular site in your, after this session will over or till tonight, and you can just try out this changing the parameters. You can just change the hyperparameters given over here, and you just try to change activation functions and see what changes are there. How are your output changes. So that was from my side, I guess.